A very good morning, dear students. Today I am going to start a new chapter, that is second chapter, electrostatic potential and capacitance. From this chapter you are going to get 9 marks. 9 marks in your annual examination. A very important chapter regarding your CET also. So potential, leave that electrostatic, just start with the potential. Already in 11th class we have studied about the potential energy or a potential, whatever, right? So I'll consider an example of spring. So when we stretch the spring, what happens? A restoring force will develop inside the spring. Okay, so in stretching a spring, what we have done a work on that spring. When we stretch that spring, that means we are going to do some work on that spring, stretching. Okay, so here whatever work we have done, that will be in the opposite direction to the restoring force. ನಾವೀಗ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದ್ದೀವಿ, ಒಂದು ಸ್ಪ್ರಿಂಗ್ ಅನ್ನು ಸ್ಟ್ರೆಚ್ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ರೀಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗಿ ಡೆವಲಪ್ ಆಗ್ತದೆ? ಈ ಡೈರೆಕ್ಷನ್ ಆಗಿ, ಟುವರ್ಡ್ಸ್ ದ ಮೀನ್ ಪೊಸಿಷನ್ ಆಫ್ ಸ್ಪ್ರಿಂಗ್. ದೆನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗಿ ನಾವೀಗ ವರ್ಕ್ ಮಾಡ್ದಂಗಾಯ್ತು? ಸ್ಟ್ರೆಚ್ ಅಂತಂದ್ರೆ ನಾವು ಅದ್ರ ಮೇಲೆ ವರ್ಕ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಟ್ಸ್ ವೈ ದಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡಿಸ್ಪ್ಲೇಸ್ಡ್ ಫ್ರಮ್ ಇಟ್ಸ್ ಮೀನ್ ಪೊಸಿಷನ್, ರೈಟ್? ಸೊ ಹಾಗಾದ್ರೆ ವರ್ಕ್ ಮಾಡಿದ್ದು ಯಾವ ಡೈರೆಕ್ಷನ್? ರೀಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸಿನ opposite direction. Is it clear? So here ನಾವೇನು ವರ್ಕ್ ಮಾಡ್ತೀವಲ್ಲ, ಆ ವರ್ಕ್ ಮಾಡಿದ್ದು, that work will be stored as a potential energy inside the spring, right? So when we leave that spring, so whatever potential energy developed inside that spring will be converted into kinetic energy, and that will bring the spring towards its mean position. It's clear, right? So there the potential energy is conserved. So which factor is responsible for potential energy there? So whatever work we have done now in stretching the spring, that is responsible for the development of potential energy. When we leave that spring, after stretching, when we leave that spring, what happens? It will regain its initial shape because of that potential energy developed due to the whatever work we have done on the spring. Okay, so now we'll develop the electrostatic potential concept based on the previous factors, right? Okay. Then what do you mean by electrostatic potential? So just look here, I will consider a system of charge, or else simply a charge. Q is the charge, right? So here I am having a charge Q. Surrounding this charge, what we are going to have? We are going to have the electric field. So ಇದು ಪ್ಲಸ್ ಚಾರ್ಜ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ? So it is radially outward direction, right? Okay, now ಎಲ್ಲೋ ಒಂದು ಇನ್ಫಿನಿಟ್ ಒಳಗೆ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಸ್ಮಾಲ್ ಚಾರ್ಜ್ ಅನ್ನು, ರೈಟ್? ಇಟ್ ಇಸ್ ಸಮ್ವೇರ್ ಅಟ್ ಇನ್ಫಿನಿಟಿ. ನೋ, ನಾನು ಇಲ್ಲಿ ಇಟ್ಕೊಂಡು ಬಾರ ಬರ್ತದೆ ಅದು? ನೋ, ಐ ನೀಡ್ ಟು ಡೂ ವರ್ಕ್ ಆನ್ ದ್ಯಾಟ್ ಚಾರ್ಜ್, ರೈಟ್? ಸೊ ಐ ನೀಡ್ ಟು ಡೂ ವರ್ಕ್ ಆನ್ ದ್ಯಾಟ್ ಚಾರ್ಜ್, ನಾಟ್ ಟು ಡಿಸ್ಪ್ಲೇಸ್ ಇಟ್ ಟುವರ್ಡ್ಸ್ ದಿಸ್ ಚಾರ್ಜ್. So whatever work I do on this charge will be stored as a potential. That is the potential of a charge, right? Okay, now here, so ಇಲ್ಲಿನೂ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅದ, ಇಲ್ಲಿನೂ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅದ. ಸೊ ಏನಾಗೈತಿ, ನಾನು ಇದನ್ನು ಹತ್ರ ತಗೊಂಡು ಬಂದೆ ಅಂದ್ರೆ ಇದು ಇನ್ಫೈನೈಟ್ ಒಳಗದ, ಇದನ್ನು ನಾನು ಹತ್ರ ತಗೊಂಡು ಬಂದೆ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ? ಎರಡದ್ರ ಮಿಡಲ್ ಏನಿರ್ತದೆ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಇರ್ತೈತಿ. ಇದನ್ನು ನಾನು ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಮಾಡ್ಕೊಂಡು ಹೋದೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿಯೂ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅದ, ಅಲ್ಲಿನೂ ಒಂದು ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅದ. ಬಿಕಾಸ್ ಆಫ್ ದೇರ್ ಚಾರ್ಜಸ್ there will be a electrostatic force of repulsion. ರಿಪಲ್ಷನ್ ಅನ್ನು ನಾನು ಓವರ್ಕಮ್ ಮಾಡಬೇಕಂದ್ರೆ ಐ ನೀಡ್ ಟು ಪುಷ್ ಇಟ್. ಇದನ್ನು ನಾನು ದುಡಿಸ್ಕೊಂಡು ಬರಬೇಕು. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಜಸ್ಟ್ ಕನ್ಸಿಡರ್ ಪಾಯಿಂಟ್ P here. Here I have point P. Now I need to move this unit positive charge at the point P. Then I need to do a work on this charge in order to move this charge from infinity to point P. Then whatever work I have done on this unit positive charge in order to bring it from infinity to the point P, that will be called as the electrostatic potential at this point. That will be called as the electrostatic potential at this point. Is it clear? Electrostatic potential. Electrostatic potential. How can we define this one? Electrostatic potential at any point is defined as the amount of work done on a unit positive charge in bringing it from infinite to that point, right? So electrostatic potential at any point is defined as the amount of work done on a unit positive charge in bringing it from infinite to that point, right? So now, this electrostatic potential will be represented with the letter V. V will be used to denote the electrostatic potential. So this is the definition. Then we have an equation for this electrostatic potential. Electrostatic potential is equal to what we have mentioned here, the work done, that is W. Work done, W, on what? Unit positive charge. I'll take this unit positive charge as a Q0. Work done on a unit positive charge. Right? Okay. Just to simplify this equation. So W means what? It is the work done. Work done is equal to force into displacement. Okay. So that is F into S. We know from the 11th class. But here we should not have to consider the total work done from infinity to point P. So then what we have to do? So first we have to move this unit positive charge towards P through a small distance dl. dl, right? So dl is the small distance that unit positive charge has been moved through. Is it clear? So I have written vector here because I mentioned the direction. Charge is moving towards point P. That's why I consider vector D. Okay. So whatever work we have done here in moving this unit to positive charge Q0 to move through small distance dl is the small work done dW. dW is the small work done in moving the Q naught through small distance dl. Okay. Then I'll write F dot, instead of S I take dl because the displacement is dl here. Okay. Right. And already we know that E is equal to F by Q naught. E means electric field. In the first chapter we have studied the electric field is the electrostatic force acting per unit positive test charge. F by Q naught. Then F is equal to E into Q naught. So dW is equal to E into Q naught into dl. Is it clear? Okay. Then here, this is a small amount of work done for a small displacement dl. Now, what is the total amount of work done in moving the charge from infinity to the point P? From infinity to point P. So then we need to integrate, because this distance from infinity to P is made up of the number of small displacements dls. Here number of small displacements together, we are going to get the total displacement. Okay. Then total work done in moving Q naught from infinity to point P is given by capital W. Total work done is integration of small work done. Integration is nothing but addition. By adding all the small work done, we are going to get the total work done. From where to where we need to add these small work done? From infinity to point P. So that is from infinity to point P. Okay. So now this equals from infinity to point P, dW means what? Vector E Q naught dl. Okay. So here Q naught is the unit positive charge, constant. So we take it outside from the integration. Integration into what? Q naught E into dl. Now we just have to substitute the value of W from this equation to this equation. So call it as equation number 2 and this as equation number 1. Substitute equation number 2 in 1. We get V is equal to W means what? Q naught integration from infinity to P dot dl divided by Q naught. Both will be cancelled. Okay. So now potential is equal to, already Q naught got cancelled. We have from infinity to P E into dl. But one thing we have to remember, we have to mention here the minus symbol. From where this minus symbol came? What is the physical significance of this minus symbol? We'll go back to the first PUC. So where we stretch the spring, there the work is done in the opposite direction to the restoring force. Work is done in the opposite direction to the restoring force. So similarly here, work is done in the opposite direction to the electric field. Work is done in the opposite direction to the electric field. How? Look here. Here also we are having positive charge. Here also positive charge. The direction of field is in this direction. Direction of field is in this direction. But work done is from infinity to p. Means it is opposite direction to the electric field. Right? So that's why we have taken minus symbol here. Okay? Right? There negative sign indicates work done is in opposite direction to the electric field. Right? So in notes, I have skipped these terms. Directly I have written after first equation, directly I have written this one in a notes. But how this comes? Through these steps. Okay?